Good morning, children. How are you all? Hope you all are keeping well. Children, in the last Zoom session, we had discussed about natural vibrations, damped vibrations, forced vibrations, the and their displacement time graphs. Children, today I am going to explain you about resonance. What is resonance? Resonance is a special case of forced vibrations. First of all, to understand resonance, I will recapitulate what are forced vibrations. See, children, what are forced vibrations? The vibrations of a body which take place under the influence of an external periodic force. Okay, which take place under the influence of an external periodic force. Then the vibrations are known as forced vibrations. Okay, children. Now, what is resonance? Resonance is a special case of forced vibrations when a body vibrates in a medium under the influence of an external periodic force of frequency exactly equal to the natural frequency of vibration of the body. It is said to execute the resonant vibrations. What does it mean? That when the external periodic force, the frequency of external periodic force becomes equal to the natural frequency of vibration of the body, then the body starts vibrates with a new type of vibration which are called resonant vibrations. In short, if I tell you, that means what are resonant vibrations? Resonant vibrations are those vibrations which take place when the frequency of external periodic force becomes exactly equal to the natural frequency of the body. Okay, children. The vibrations are known as resonant vibrations. Now, these vibrations are some different. Yes, these vibrations are of larger amplitude as compared to forced vibrations or natural vibrations or damped vibrations. These resonant vibrations are of larger amplitude. The amplitude at resonance depends on the frictional forces. If the frictional forces of the medium are less, the amplitude will be more. Thus, definition we can give of resonance is what? It is a special case of forced vibrations when the frequency of the externally applied periodic force on a body is equal to its natural frequency. The body readily begins to vibrate with an increased amplitude, and this phenomena is known as resonance. Okay, children. Now, suppose a body is said to vibrate freely and it vibrates with a frequency f. Suppose, let's say, a body is vibrating. We have given a natural frequency, that is f. This is the natural frequency of the body. Now let a periodic force of frequency n be applied on the body. Now let the body is initially the body is vibrating with a natural frequency f. Now we are giving an externally applied periodic force of frequency n. If n equals to f, that means if frequency of externally applied periodic force is equals to the natural frequency of the body, then what happens? The resonance takes place and the body starts getting energy from the source of the applied periodic force. Now the body is getting energy. From where it is getting energy? The body is getting energy from the force where we are giving externally applied periodic force. So its amplitude of vibrations also increased. Okay, in case this resonance is only the case when the externally applied periodic force is equal to the natural frequency of the body. It may also not, it may every time it will not happen. Maybe sometimes n is greater, that means frequency of externally applied periodic force is less than or greater than. Then at that time resonance will not take place. There will be no resonance and the body will execute only the forced vibrations of small amplitude. If resonance does not take place, then the body will vibrate with which frequency? Let's say first case was that when n equals to f. When n equals to f, then the body will vibrate with which frequency? Since both are equal, the body will have a larger amplitude. But when n is greater than or less than f, then what will happen? Then the body will vibrate with not with its natural frequency but with the frequency of the externally applied periodic force, and which is of smaller amplitude. Okay, children. Now, condition for resonance, it sometimes comes in exam. Give the condition for resonance. What is the condition for resonance, children? Resonance occur only when the frequency of applied periodic force and the natural frequency of the body is exactly equal. At that time only resonance will occur. Okay. Now at resonance, a loud sound is heard or a amplitude will be larger. Why it happens? Because the body vibrating with a very large amplitude send forth its energy into the medium, due to which what happens, a loud sound is heard. Always remember, at resonance the body will vibrate with a larger amplitude and a loud sound is heard. Why a loud sound is heard? Because since it is a larger amplitude, so it will send forth its energy into the medium as well, and the body will produce a loud sound. Okay, now demonstration of resonance, children. We have 3 experiments given in the book.